Now we're going to look at two businesses and see how they make decisions in order to help them maximize profits using this technique that we call linear programming.
Belgian chocolates are famous the world over, but there are many different kinds of chocolate that can be made. How can the producer pick the best combinations within the various constraints imposed on the business? We see how the mathematics of linear programming can help to give an insight into this question. Our tomato grower has focused entirely on different varieties of tomato. Is it time to diversify and produce another product entirely? This will depend upon a whole series of factors, including the time it will take to care for a different crop, the limits of greenhouse space, and the commitment he already has to supply tomatoes to retail outlets. Does it make sense for him to give up some tomato production? The use of mathematical principles of linear programming will enable us to understand the answer to this. In the second part of the film, we begin to examine non-linear mathematical techniques. We begin with competitive industries, and we'll see that many industries have supply and demand curves that can't realistically be thought of as linear. So how can we forecast the price and output of such industries? Then we turn to labour markets. It's often the case here too that we'll need non-linear functions to find employment levels and wage rates. The mathematics of non-linear equations will help us to arrive at a better understanding of these and related issues that are raised in this film. In the last section of the film, we introduce a problem for firms that we solve by differential calculus. We look here at industries where firms have more power to set prices. We then see that calculus can help understand macro issues also. In this case, we examine consumption and saving behaviour. Belgian chocolate is famous throughout the world, and the Belgians have a reputation for fine craftsmanship with chocolate.
What makes it special? What is it about Belgian chocolates that gives it its reputation?
Well, Belgian chocolate is not always everywhere the same. You mean you have Belgian chocolate that's made industrial, but you have also Belgian chocolate that's made handmade.
Right.
And that means that the quality of their chocolate is higher. And they had a regulation in Belgium, if we made chocolate for the Belgian market, we were obligated from the government only to use pure cocoa butter in our chocolates. 100% pure cocoa butter.
Right.
Other countries, Scandinavia, almost every other country in Europe had another regulation that means that if cocoa butter was very expensive, they put other vegetable oil under their chocolates.
Chocolatière Barry is one of many chocolate factories in Belgium.
There are supermarkets that sell chocolate and they sell it a lot cheaper than you do. Yeah. So why are people prepared to pay so much more for these?
Or it's all fresh, you really taste it. We made it all with hand, and so it's a lot of work. Or you taste it. Yeah.
All the chocolates produced here are created by hand using fresh ingredients. This makes their chocolates more costly to produce than machine-made chocolates.
What makes the quality difference is also the filling that we use in our candies. We use good butter, cream, eggs, no preservatives. We have here orange peel. It's a specialty sugared orange peel. We still sugar our orange peel ourselves, as you can see.
Yeah.
And this takes for about 3 or 4 weeks. This is no preservatives, the old-fashioned way of conserving fruit, and that gives it a very high cost. But this is the only way you can say this is quality.
Yeah.
The price is also, of course, higher.
Sure.
Let's assume that they'd like to increase production by making some chocolates by machine and some by hand. What's the best amount to produce of each type? In other words, how do they make sure that the amounts of each sort that they make are optimal? They cannot simply make any amount they choose because they're constrained in all kinds of ways.
It's very difficult now to find people in very specialized trained people for a long time commitment.
Let's assume the following constraints. Let's assume that there are 36 people who work in the factory and they work a 36-hour week. That represents a maximum of 1,296 hours of labour time each week. Overtime is clearly possible, but it's very expensive, so the company doesn't regard this as a meaningful option. They have 1,824 hours of machine time each week, and a batch of handmade chocolates requires 18 hours of labour time and 6 hours of machine time. A batch of machine-made chocolates requires only 4 hours of labour time, but 12 hours of machine time. Chocolatier Bury wishes to use its labour and machines as much as possible. Furthermore, the deluxe handmade chocolates make 89 euros a batch in profit, but the standard chocolates make only 55 euros a batch profit. What does the mathematics of linear programming tell us about the best way for the chocolatier to organise production so as to maximise profits? Now there are 7 steps, but we'll focus for a time on just the first 5. And these are: first, identify the unknowns and label them in some way, X and Y or whatever. Second, write down an expression for the objective function, the thing you wish to maximise or minimise, and express it in terms of X and Y. In this case, we've got something to maximise, profit. Other times it might be something to minimise, such as the cost of doing something. Third, write down all constraints on the variables X and Y. Fourth, write down any obvious constraints, such as which you may have forgotten about. Often these are non-negativity constraints. Here, for example, the output of batches of chocolate can't be less than 0. And fifth, graph the constraints in order to find the feasible area. That is, all the options that are possible. Just what choices does our chocolate manufacturer have that he can consider? So let's work through these 5 steps. Then afterwards, we can see how to finish the problem by picking the best combination of chocolate batches for maximising profits. Here we follow a series of steps in linear programming to determine how a Belgian chocolate producer should allocate his resources to maximise profits. In this case, we want to find the optimum number of batches of machine-made chocolates that we'll call M, and handmade chocolates that we'll call H. Now, since a batch of M makes 55 euros profit and a batch of H makes 89 euros profit, our objective function can be written as maximise 55M plus 89H. But he has to do this within a series of constraints. First, there's a labour constraint. The handmade chocolates, H, needs 18 hours for each batch, and M needs 4 hours for each batch, and the total hours available is 1296. So the constraint is 4M plus 18H is equal to or less than 1296. We also have a machine time constraint. Each batch of M needs 12 machine hours, and each batch of H needs 6, and the number of machines available limits us to a total of 1824 hours. So our machine time constraint is 12M plus 6H has to be equal to or less than 1824. But there are also some non-negativity constraints. Batches of each type can't be less than 0, so we also require that H is equal to or greater than 0, and m is equal to or greater than 0. Now we haven't yet found the best combination of handmade and machine-made chocolates for maximising profit, but what we have done is to establish the nature of the problem. We now have an objective function and we know what the constraints are within which we have to operate. So we now have a problem in a form which is soluble.